there any advantage of serial LiDAR?
Yes, I mean, there are different modalities. So LiDAR is sparser because you have to, well, there's many different forms of LiDAR. So scanning LiDAR is typically sparse. So LiDAR, if you guys don't know, is a time-of-flight laser rangefinder that generates, it gives you a point cloud, basically. So the downside is we're not flying LiDAR in any of the Mars missions. They draw a lot of power, and they typically have moving parts. And so in the thermal environment of Mars, like only now are they starting to certify LiDARs that can work in that environment. But when all of these missions flew, there was no viable LiDAR that could flow. So that was one key limitation, just the technology wasn't ready. The advantages, I mean, LiDAR gives you, it's kind of invariant to lighting conditions. So LiDAR works at night, works in the dark, works in shadow, whereas stereo has problems in all those places. But LiDAR doesn't see texture, it doesn't really see like albedo, and it doesn't give you a very good way to be able to estimate terrain properties like sand versus bedrock. So for the most part, they're complementary. They're not orthogonal, but they are two different modalities of sensing and plan and navigate using either in independence. But a lot of our research robots use both in conjunction.
Are you using a lot more automass with Perseverance?
Yes. Yeah. So Perseverance is driving almost well over 90% of its distance driven is autonomous now. So it's in fact in the last month or so it just overtook the. Well, I think it's beaten the record of Opportunity for a while now. But it drove about 410 meters autonomously, which is the furthest any vehicle has driven on Mars. Which doesn't seem like a lot, but by the standards of how fast these rovers move, that's a lot. Yeah, there's a wide spectrum of wavelengths that is of interest, all the way down to long wavelength radio. That, like DSN, actually can do a lot of radio astronomy through those antennas, but they don't work in the optical realm. So it depends on the science.
What's the intent of these panels that blocks the rays?
Yeah, it's just like the baffles of the camera lens, so it prevents emissions from stray emissions that come off axis light. So yeah, it's just a shield to prevent stray light from entering the telescope. Yep.
What's the low pressure?
I don't know. It might be on that information card.
We're still getting data from Hubble?
We are. I believe Hubble is working on one. So the way that all of these spacecraft maintain attitude is through reaction wheels, and I believe only one axis of controlled reaction is working on Hubble. And so I don't think it's that useful as an instrument anymore because they can't point it reliably. They kind of ran out of tricks. I mean, the reaction wheels have been failing on Hubble for a decade or two. The tool arm, all of the sample tubes that has a mirror on the bottom, so the sample tube storage chassis is underneath the rover. You can kind of see that it's partially populated. The purpose of the rover is to do sample collection. So the arm will drill a sample, collect that sample, and then put it in that assembly. Otherwise, it's very similar in capability to Curiosity.